So yeah, hello everyone. A very good evening to one and all of you. So I hope I'm audible and visible. So if anyone of you can confirm it.
Yeah, ma'am, you are audible.
Okay. So let's wait for 5 to 10 minutes so that everyone can able to join the session. People are joining now. So we will wait at least 5 minutes. Then we will start the session. Okay, so let's start the session. Hello everyone, my name is Pooja Verma, and PMRF Research Scholar from IIT Kharagpur, and instructor for this course is Professor Samal Kumar Das Mandal, Advanced Technology Development Center, IIT Kharagpur. This is a week 4 live and interactive session on signal processing techniques and its applications. Okay, so you can use the chat box for asking and interacting. Otherwise, you can unmute yourself and ask your questions and doubts. Okay, so I hope all of you have gone this week video lecture. So for this week, this is a course content which have been covered for this week. So the course content related to this week is frequency domain representations of a discrete signals and LTI system. Then next one is discrete time Fourier transform, discrete Fourier transform, and discrete Fourier transform, linear transform view. And next is properties of the discrete Fourier transform. Okay, so first we will go through some theoretical concepts, then we will solve the problems which may be helpful during you solving your assignment problems. Okay, so first one is the frequency domain representation of a discrete signals and LTI system. So frequency domain representation of a discrete time signal and LTI time invariant systems provide insights into their spectral characteristics, filtering behavior, and system response. And frequency domain representation of a discrete time signal, that is the x of n, can be represented in the frequency domain using either discrete time Fourier transform or discrete Fourier transform. So first we will see the discrete time Fourier transform. So what is discrete time Fourier transform? Thus the discrete time Fourier transform of x of n is represented by this equation, by this equation, that is x e to the power j omega is equal to n is equal to minus infinite to infinite x of n e to the power minus j omega n, where discrete time Fourier transform is a representation of a continuous. It is represented as in continuous time signals where omega is a normalized frequency. It is a normalized frequency. It is represented in radians per sample. Okay, and the magnitude response, that is x e to the power j omega mod of, shows the strength of a frequency component where the phase response, that is x e to the power j omega, that phase of that one, represents a shift at a different frequency. DFT is continuous in omega with and a periodic with period 2 pi. Okay, now next one is discrete Fourier transform. So what is a discrete Fourier transform? Discrete Fourier transform is a finite duration signal representation of a discrete time signal. It is represented in a finite duration. That means where we are representing the whole signal in a finite duration, in some duration. That duration is n till n minus 1. So it is represented by the DFT is represented by x of k, and the formula is summation n belongs to 0 to n minus 1, that is finite duration, x of n e to the power minus j 2 pi n kn, where k varies 0 to n minus 1, and where n is the number of points in the DFT, and that DFT provides discrete frequency representation of a x of n, that is DFT of x of n is x of k, and the inverse DFT, that is discrete Fourier transform, recovers x of n from the x of k from this equation, that is 1 by n summation k varies 0 to n minus 1 x of k e to the power j 2 pi by n k n. DFT is computed efficiently using the fast Fourier transform algorithm. Okay, fast Fourier transform is an algorithm that is used to compute a discrete Fourier transform. It is a not type of DFT or not a in the type of TTFT. It is an algorithm to solve the discrete Fourier transform. Now, for an LTI system, the input-output relation in the frequency domain is represented by this equation. Already we know that shows the convolution in time domain. That is y of n is equal to x of n convolution of h of n. That corresponds to the multiplication in the frequency domain. Already we have seen this one. And that magnitude response, that is h of e to the power j omega, determines, already we know that it is a transfer function which determines the gain or attenuation at each frequency, where the phase response of that is determined the phase shift at each frequency. And that how that h of z and h e to the power j omega is related. The relation between the DTFT and Z transform is represented by this equation, where Z is equal to e to the power j omega. Okay, this is a relation of Z transform of DTFT. It can be asked in many places, in many competitive exams, and that can be asked in your during your exams also. This, what is the relation between the Z transform and DTFT? How the Z transform can be transformed into the DTFT. Okay. So now next one is the properties of a DTFT. So first one is a linearity property. So if two signals x of x1 n and x2 n can be a linear, can we follow the linearity property if they are additivity and homogeneity in nature, if they follow the superposition theorem. So already we know that there are two signals x1n and x2n, and their corresponding DFTs are x1 e to the power j omega and x2 e to the power j omega. Then the signal, the linearity property is defined by this equation: ax n x1n plus b x2n is equal to a x1 e to the power j omega plus b x2 e to the power j omega, if they follow the linearity property. Otherwise the signal is non-linear. Okay, now next one is a time shifting property. So if we have signal x1 xn and their corresponding DTFT is x e to the power j omega, then the shifting in the time, that means x n minus n naught, can be shifted into the frequency domain, that means e to the power minus j omega n naught x e to the power j omega. Okay, now here it is a time shift, that means shifting in the time, and here shifting in the frequency. If we shift in the corresponding frequency, what will be the corresponding DTFT? That is x1 e to the power j omega naught. Here we are shifting by omega naught in the frequency, then corresponding DTFT will be this one, x e to the power j omega minus omega naught. Now next property is convolution property. If there are two signals x1 and corresponding their DTFT is x1 e to the power j omega, and the other signal is x2 of n and their corresponding DTFT x2 e to the power j omega, then the convolution in the time domain, we can write into the frequency domain the just multiplication of these two signals. Convolution in the time domain, then if we represent into the frequency domain, they are simply multiplication into the frequency domain. Now next one is a Parseval's theorem. So Parseval's theorem used to find out the total energy in the time and frequency domain signal. If a signal x of n, if we need to find the energy of in the time Then corresponding the frequency domain representation is this one, 1 by 2 pi, where integration minus pi to pi x e to the power j omega mod of whole square d omega. Now next one is some properties of the DFT that is very similar to DTFT. That one, the linearity. Already we know that if two signals x1 and x2, and then linearity property is and their DFT x1k and DFT of x1n is x1 of k and x2 of n, their corresponding DFT is x2 of k. Then linearity property follows this where additivity and homogeneity that follow the superposition theorem if the signals are linear. Now next one is a periodicity property. So already we know that a signal is periodic if x of n is equal to x n plus n. Then they are in the frequency domain that correspond to the same shift in the and the periodic. If they are periodic in the frequency domain, then they follow this equation, xk plus n is equal to x of k. Then similarly the time shift, if the shifting in the time domain by n naught, then corresponding DFT signal is into the frequency domain is represented by x of k e to the power minus j 2 pi by n k n naught. Okay, here shift corresponding shift into the frequency domain by this n naught. Now next one, frequency shift. If there is a frequency shift into the time domain signal that by k naught, then the corresponding DFT signal is xk minus k naught. And next property is conjugation, x conjugation, and then corresponding that frequency domain representation of a DFT, that is x conjugate of minus k mod n. And now next one, time reversal. If they are reversed by a time where n is the number of points, okay, where we have to DFT is a finite time duration signal, so it is a finite duration length, that is n minus n. Then corresponding their frequency domain representation is x conjugate of k. Now Parseval's theorem, same as here it is misprinted, so it is the same as a DTFT, but here just similarly n belongs minus infinite to infinite or the x of n whole square, then corresponding DFT by 1 by 2 pi minus pi to pi, no, it is a x of k square, not a pi minus pi, it is summation whole square. Okay, now next one is a circular convolution, or simply you can say that convolution. Just a minute. Now next one, convolution or circular convolution. The circular convolution is represented by this one. If there are two signals x1 of n and x2 of n, then their frequency domain representation is simply a multiplication into a frequency domain, x1k into x2k. Now next is duality property, that is x of n. The duality property of x of n is represented by n x of minus k. Now next one, differentiation. Differentiation in the time domain corresponding frequency shift into the frequency domain. Okay, this is a frequency domain representation of a differentiation in the time domain. Now next one is a discrete Fourier transform, that is a linear transform view. So discrete Fourier transform as a linear transform that converts discrete time sequence into the time domain to the frequency domain. It can be viewed as a matrix vector multiplication. Okay, similar to other linear transformation in linear algebra. So already we know that the DFT is an n-point discrete time sequence that is represented by this equation: x of k is equal to summation n belongs to 0 to n minus 1 x of n e to the power minus j 2 pi by n kn, where k varies 0 to n minus 1. That can be written in the matrix form by this equation: x is equal to w x, where x is the frequency domain representation, it is a matrix, and this is a time domain segment. So we will see on that. If there is a x is an input vector that varies x 0 to, and it is written like this, and x varies 0 to n minus 1, then capital small x is the input vector and capital X is the DFT output vector. Okay, it is represented by capital X to the power 2 x n minus 1, and W in the DFT matrix of n cross n matrix is represented by this equation, where W k and k is represented by this e to the power minus j 2 pi by n k n. The whole equation can be written like this, the whole DFT. Okay, here the DFT of an output vector, it is an input vector, and this one is a W, where W already we know that is represented by this one. Here only W e to the power minus j 2 pi by n. If it is written W k n, then it can be written as 2 to the power 2 pi by n k n, where this one will be whole n, and here W, W2, Wn minus 1, it will be vary to n minus 1. It is a discrete Fourier transform in linear transform view. Now next we will move some questions. We will solve some problems. Okay, so question number 1 is the DTFT of a finite sequence x of n is given by this sequence is given by. How we can solve? Which option is correct? Can you try? Would you like to try this question? Which option will be correct? What is a DTFT of a finite sequence which is given as x of n is equal to 1? That the arrow represents it start from 0. That means 0, this one is 1, this one is at place of 2, this 5 represents at place of 3. Okay, so what is a DTFT of the given finite duration sequence? Please try to answer in the chat box. Yeah, anyone of you solving this question? Just try to solve it. I will solve it within 1 second. I will start solving. Try to solve this question and answer in the chat box. Okay, so already we know that the DTFT of a sequence x of n is defined as the DTFT is defined by x e to the power j omega is equal to n varies minus infinite to infinite x of n e to the power minus j omega n. Right? Here our n varies from where to where? 0 to 3. Right? So n is equal to 0 to 3 x of n e to the power minus j omega n. Now if we open this summation, then what will if we first put x of 0, n is equal to 0, x of 0 e to the power, that will whole will be 0. Here we are putting 0 1 2 3 till 3, so e to the power 0. Now next we are putting n is equal to 1, so x of 1 e to the power minus j omega plus x of 2 e to the power minus j 2 omega plus x of 3 e to the power minus j 3 omega. In place of n, we are putting 0, 1, 2, 3 because it varies from 0 to 3. Okay, now we will put, this is the x of 0 value is 1, right here. So 1 into e to the power 0, that is 1. So 1 only. Now next, x of 1 value is 3, right? So plus 3 e to the power minus j omega plus what is the value of x of 2, that is minus 2. So here we can directly write it minus 2. In place of plus it should be minus. So minus 2 e to the power minus j 2 omega. Now what is the x of value x of 3, that is 5. So 5 e to the power minus j 3 omega. Okay, so they have asked in this form only. So this is the final answer. So let's see which option is correct. 1 plus 3 e to the power minus j omega minus 2 e to the power minus j 2 omega plus 5 e to the power minus j 3 omega. Which option is correct? Which one is matching? That is option B. Option B is the correct answer for this question. Okay. Okay, I hope you have understand this question. So moving to the next question. Okay. So next question, a discrete time LTI system is given in figure 1, that is whose frequency response is given by h e to the power j omega, that is this one, and input is x of n is equal to e to the power minus j pi n, where n is an integer. So this is a LTI system where input is x of n and their frequency response is of an LTI system is h e to the power j omega and their output is y of n. Then the output of a given system, what will be the output of a given system? So anyone of you want to solve this question? Try for this one. Everything is given and already we know that what is the input, output and a frequency response relation. Okay, here it is given y of n is equal to h e to the power j omega into x of n, or we can write it convolution of x of n, right? So if we convert it into the frequency domain, so h e to the power j omega and then corresponding in the frequency domain, it is multiplication of x e to the power j omega. So h e to the power j omega is same, but what is the x of e to the power j omega given? That is this one, x of n, right? So e to the power minus j pi n. Okay. So now can we e to the power j omega, can we write it like this? So here a discrete time LTI system would, okay, to the power j omega x of n, where n is an integer. So here also we are assuming that the frequency response of an LTI system h of e to the power j omega, and input is x of n e to the power minus j pi n, which is a periodic and with frequency omega is equal to pi. Okay, h e to the power j omega is a periodic signal with period omega with frequency omega is equal to pi. Okay, assume. So now e to the power j omega is equal to e to the power j pi. Okay, we can write it like this. Then how we can write it? E to the power j pi cos pi plus j sin pi. We can write it like this. So now h cos pi plus j sin pi. Just changing it. Okay, e to the power minus j pi n. Now what is the value of cos pi and sin pi? What is the value of cos pi and sin pi? So cos pi is minus 1 and sin pi is 0. Okay, e to the power minus j pi n. So that will be 0 only. So h of minus, we can write it h of minus 1 e to the power minus j pi n. Okay, so which option is correct? The final answer is I am writing here. So e to the power minus j pi n h of minus 1. Okay, so from here the option A is the correct answer. Okay, okay, so have you understand this question how to solve? Can you answer in the chat box? Can we move to the next question? Have you understand this question? Okay, so I hope all of you have understand. So moving to the next question. So next question is, okay, so now next question is identify the correct options for the frequency response of a discrete time LTI system. So option A is a magnitude response, order function of frequency, and phase response is even function of frequency. Option B is magnitude response, even function of frequency, and phase response is odd function of frequency. Option C is magnitude response is even function of frequency, and phase response is neither even or not odd function of frequency. And option D is none of these. So can you answer in the chat box which option can be a correct one? At least you can try just. Okay, option B. Okay, yeah, option B is the correct one. Great. Okay, so I will elaborate this question. So yeah, option B is the correct answer. So the frequency response or discrete time LTI system, magnitude response is a even function of frequency, and phase response is odd function of frequency. Okay, so how? So for a discrete time LTI linear time invariant systems, the frequency response is h e to the power j omega. Already we know that is a complex function, and that can be represented by two parts. That is mod h e to the power j omega. This is the end. The other part is the phase. Okay, this is a magnitude, and another part is e to the power j, e to the power j omega. Okay, phase response, where h is a magnitude response and this part represents the phase response. So magnitude response, where h e to the power j omega can be represented by mod of real square h e to the power j omega plus imaginary square h e to the power j omega. Okay. Since h e to the power j omega and h e to the power minus j omega are the complex conjugate, so h e to the power j omega and h e to the power minus j omega are the complex conjugate. So mod h e to the power j omega must be equal to h e to the power minus of j omega. Okay, that shows the magnitude response is an even function. Okay, now next one is a phase response. So already we know that the phase response is represented by this, and it can be defined by tan inverse imaginary by real, right? H e to the power j omega, and here h e to the power j omega. And already we have defined that h e to the power j omega and h e to the power minus j omega are the complex conjugate. Then phase response satisfies h e to the power minus j omega minus h e to the power j omega. Okay, that shows that phase response is an odd function of frequency. Okay, so that's why option B is the correct answer for this question. Okay, so moving to the next question. Now next question is, if the sampling frequency is 200 kilohertz, then for a frequency f is equal to 25 kilohertz, what will be the value of normalized discrete frequency in radian per second? What will be the normalized discrete frequency? Can we solve this question? This one is easy. And solve, try to answer in the chat box. Within 1 minute, I will solve this question. So here sampling frequency is given, that is 200 kilohertz, and frequency, that is variable frequency, is given 25 kilohertz. Okay, so already we know that the normalized frequency discrete frequency is defined by, it is defined by f dash. So what will be the frequency divided by the sampling frequency? Okay, that is 25 kilohertz divided by 200 kilohertz, that is equal to 1 by 8. Okay, so normalized discrete frequency is represented by discrete frequency represented by omega dash simply, and it is written as 2 pi f, right? Omega is written as 2 pi f, that is 2 pi f dash. Okay, so now put the value of f dash here, then you will get it. So 2 pi into 1 by 8. So 4, that is pi by 4. Okay, so now like discrete frequency is 2 pi by 4. That is correct option is option C. Option C is the correct answer for this question. Okay, okay. So I hope you have understand this question. So moving to the next question. So now next question is the n is equal to 4, that is 4-point DFT of a sequence is given x of n 1 2 3 1 is. What is a 4-point DFT of the given sequence? That arrow represents that it starts from 0. That means it is a 0. So 0, it is a value at position 1, it is a value at position 2, and it is a value at position 3. Okay, so how we can solve this question? What will be possible answer? Okay, so first way to solve this question, already we know that what is the formula of a DFT? It is represented by x of k is equal to n varies from 0 to n minus 1, x of n e to the power minus j 2 pi by n k n, right? The DFT is represented by this equation. You can solve this way. Otherwise, there is a one four. If there is a 4-point DFT, we can directly calculate by other way also. So 4 point to calculate the 4-point DFT directly, this is a formula. So x of k, where k varies 0 to n minus 1. So here n is equal to 4. So that means 0 to n minus 1, that is 3, right? So x0, x1, x2, x3. Okay. So here I am writing only x of k. So this is a shortcut. 1, 1, that is a linear transform view, which we have seen. That means this is a double equation. So 1 j 1 j. So it is 1 minus 1 1 minus 1. Now next is 1 j minus 1 and minus j. Okay, now and this side the time domain signal. Okay, that means x of 0, x of 1, x of 2 and x of 3. Okay, this is a output vector, right? X of k. Yeah, someone, Jaya Kumar, if you want to ask some questions, otherwise can you unmute yourself? Yeah. Okay, now put the values of x0, x1, x2 and x3 and solve this. So 1, 1, 1, 1, 1 minus j minus 1 j. So now 1 minus 1, 1 minus 1. Now next one is 1 j minus 1 minus j. So by putting values 1, 2, 3, 1. Okay. Now I am taking it to this side. So directly multiply by row into column. So if you multiply by this row to this one, then this row to this one, this row, and add these. simple matrix multiplication and addition. Okay, so 1 multiplication by 1 is 1, then plus 1 multiplied by 2, that is 2, then plus 1 multiplied by 3, 1 by 3, 1 multiplied by 1, so that is 1. Okay, now next this row and then multiply and add by this one. So 1 into 1 is 1, here minus j is there, minus j into 2, that means minus 2j. Now next one minus 1 into 3, that means minus 3, then j into 1, so plus j. Okay, now next multiply the third row into this column. So 1, then minus 1 into 2, minus 2, 1 into 3, that means plus 3. Now next one minus 1 to 1, minus 1. Now similarly multiply this row to this column, that means 1 plus 2j minus 3 minus j. Okay, so now I have to remove from here also. Just remember this matrix, this one is very important. Okay, so here just add this. So 3 3 6 1 7. Now next one is 1 minus 3 is minus 2, minus 2j plus j is minus j. Now next 1 minus 2, that is minus 1, so just 1 only, right? So minus 2 minus 1 minus 3 minus 3 plus 3 is cancelled out, 1 only. Okay, so now next one is 1 minus 3 is minus 2, 2j minus j is plus j. Okay, so this one is a final 4-point TFT, that is x of k. Okay, where k varies 0 to 3. Okay, that means values is x of 0 is 7, x of 1 is minus 2 plus minus j, x of 1 is x of 2 is 1, and x of 3 is minus 2 plus j. So which option is matching with this one? That is option D. So option D is the correct answer for this question. Okay, so this matrix is important for calculating 4-point DFT. Just remember it. If you want to calculate more than 4 points, then you have to use direct formula, that one DFT formula. Okay, so this one is a calculation of 4-point DFT, this matrix, W matrix. Okay, okay, so I hope you have understand this, how to calculate this one. So moving to the next question. Now next question is, how many complex additions and multiplications required to compute 8-point DFT? So would you like to answer this question? This one is the easy one. So just I'm going to tell you the formula. What is it? How to calculate the complex addition and multiplication to n-point DFT. Okay, here n is given as n is equal to 8, because they are asking for to compute a 8-point DFT. That means n is equal to 8. Okay, so for n-point DFT, n-point DFT, total number of complex addition can be calculated by this equation, n minus 1. Okay, and to calculate the total number of complex multiplication, total number of complex multiplication is n square to compute for n point TFT. So total number of complex addition is n in bracket n minus 1, and to calculate total number of complex multiplication is n square. Okay, so here already n is equal to 8 given. So can you compute it and answer in the chat box? So they are here representing the complex addition by P. Complex addition is represented by P, and complex multiplication is represented by Q. So what is the value of P and Q? Can you answer in the chat box? Please try to answer in the chat box. This one, just I have given you formula, just put the value of n and find it out and just answer in the chat box. What is the values of P and Q? Okay, yeah, answer this. Yeah, correct. Okay, great, English. Okay, so just putting the values of n. So n is equal to 8. So 8 minus 1 here. So that means 8 into 7. That is equal to 56, right? And for complex multiplication, that is n square. That means 8 square. That is equal to 64. That means P is equal to 56 and Q is equal to 64. Okay. So option B is the correct answer for this question. Okay. So moving to the next question. Now next question is the 8-point DFT of a signal x of n is given as del n minus 2 del n minus 1 plus 3 del n minus 3 is. What will be the DFT of this signal? So x of, we need to find out x of k. Okay. So here it is given 8-point DFT, that means n is equal to 8. Okay, but they have given the impulse response. That means it is given at n is equal to 0 only, at n is equal to 1, at n is equal to 3, and all other places the values are 0. Okay, so just we need to find out at n is equal to 1. So what will be the DFT of at these places? So at n is equal to 0, the value is 1. At n is equal to 1, value is minus 2. And at n is equal to 3, value is 3. Okay. So already we know that the DFT of any sequence is represented by x of k, which is equal to n is equal to 0 to n minus 1 x of n e to the power minus j 2 pi by n k n. Okay. So just put x of n. So n is equal to 0 to n minus 1, where n is 8. So 8 minus 1, that means 7. Okay, I'm writing it here 7. 7, just put the value of x of n, that is del of n minus 2 del n minus 1 plus 3 del n minus 3 and into, I'm removing it from here also, e to the power minus j 2 pi by a k n, right? Now already we know that it is an impulse function, so n at n is equal to 0, it is the value, and all other places it is 0. Okay, so here it is a 1, and multiply all these factors into this one. So 1, or we can further solve it, or otherwise we can directly write it here also. So just okay, we can include one more step. So del of n e to the power minus j. So yeah, just pi by 4 we can write it. 2 pi by 8 is pi by 4. Kn minus 2 del n minus 1 e to the power minus j pi by 8 kn plus 3 del n minus 3 e to the power minus j pi by 8 kn, right? Now just put the values of n, then we will find out. As impulse response values are only values are at n is equal to 0, 1 and 3, and all other places are 0, otherwise 0, right? So just put it here. If n is equal to 0, then 1 into e to the power that n is 0, so it will be 0, right? So here it will be 1, only 1 into e to the power 0, so right, minus 2, it is at n is equal to 1, so e to the power minus j pi by 8 k, n is equal to 1 is here. Now next one is plus 3 at n is equal to 3, so put n here, e to the power minus j 3 pi by 4 k, right? So it is 4 here, all these places 4 pi by 4 only. Okay, so now if we further solve it, so we can write it 1 minus 2 e to the power minus j pi by 4, not 8, 4k plus 3 e to the power minus j 3 pi by 4k. So this one is the final answer. Just match it. Which option is correct? Which option is correct? 1 minus 2 e to the power minus j k pi by 4 plus 3 e to the power minus j 3k pi by 4. That is option D. So option D is the correct answer for this question. Yeah, option D is the correct answer. So yeah, Anis, you are solving with me?
No, ma'am, I am not solving. I'm just listening a bit.
Okay, try to solve it with me.
Actually, I'm traveling, so
Okay, no issue. Yeah, okay. So moving to the next question. Now next question is the endpoint DFT of a complex exponential signal, that is x of n e to the power minus j omega naught n, is what is the endpoint DFT of this signal? So okay, already we know that the equation to solve the DFT problem. So that is DFT equation, DFT defined by x of k, and it is equal to n is equal to 0 to n minus 1 x of n e to the power minus j 2 pi by n k n, and here x of n is given n e to the power minus j omega naught n. just put the value of x of n here. So here it is, n is also not defined, so we need to find out in that form only. Okay, so n is equal to 0 to n minus 1. X of n is equal to e to the power minus j omega naught n e to the power minus j 2 pi by n k n. Right, now if we solve this further, so e to the power minus j, we need to take this one common, so minus j and n is common in both these terms, so omega naught plus 2 pi n into k, and n is also we need to take common. Okay, now what is the formula? Already we know that if n belongs to n to 0 to n minus 1 r to the power n, it is written as, from the geometric series expansion, 1 minus r to the power n, capital N, divided by 1 minus r, for r is not equal to 1. Right, now expand in this form, so what we will get? So 1, so 1 minus r is e to the this part, right, e to the power minus j omega naught plus 2 pi by, from the geometric series expansion, n k n into n, right, capital N, divided by 1 minus r only, so that r is this part, so e to the power minus j omega naught plus 2 pi by n k. Okay, so this one, now we need to, because it is written in another form, so further we need to solve it. We can expand this one, because here N capital N will be cancelled out, then we will get some other equations also. Okay, so after here I am writing here. Okay, here, so I am just expanding this part, so 1 minus e to the power minus j omega naught n, right, plus, sorry, minus would be here, at e to the power minus j, so 2 pi by n, so n here will be cancelled out, so we will get only 2 pi k, right, 2 pi k. Now in the lower part it is same, e to the power minus j omega naught 2 pi by n into k. Okay, so as we already know that this part e to the power minus j 2 pi k, further we can write it in the form of cos 2 pi k minus j sin 2 pi k. Here k is an integer value, so it is a finite duration, so in generalized form we can write it equal to 1. Okay, so if we take e to the power minus j 2 pi k is equal to 1, then that equation will be 1, right? So here we will get 1 minus e to the power minus j omega naught n divided by 1 e to the power minus j omega naught plus 2 pi by n k. Okay, so now this, after expanding, we will get the final equation is this. So from here option B is the correct answer for this question. Okay, after expanding this equation. Okay, so I hope you have understand. So moving to the next question. Okay, so now next question is the given sequence x of n is 4, 3, 2, 1, 2, 3 is. Option A is 6-point circularly antisymmetric, or option B is 6-point circularly odd, or option C is 6-point circularly even, or option D is none of these. So sequence is given as 4, 3, 2, and that arrow represents it starts from here. That means at it is represented at position of 0. Okay, at position of 0 the value is 4, then it represents at position 1, it represents at position 2, 1 represents at position 3, it is at position 4, and it is at position 5. So 0 to 5, that means it is a n is equal to 6 points are there. Okay, so that means 6 points circularly. Now whether we will see that whether it is a circularly even, circularly odd, or anti-symmetric. So n point circularly even, what will be the equation should we follow? N point circularly even if x of n is equal to x of minus n, right? We know that. That means if it is n point in the DFT, we can write it equal to x is equal to n minus n, right? And if it is circularly odd, so it must be follow, if circularly odd, so x of n is equal to x of minus n. This is the odd function. X of n is equal to minus x of minus n. So that can be written as x of n must be equal to minus x of n minus n, right? In the form of DFT. And for antisymmetric, it is same. Okay, for circularly antisymmetric, it must be same. That means odd also. That means it is not a symmetric function. So that follows the circularly odd function only. So for antisymmetric, it is the same equation. So let's check either x of n is equal to x n minus 1. So already we know that, as we know that x of n for any function, if x of n is equal to x n minus, it is not equal, then it will be the circularly odd or antisymmetric. Okay, so let's check for first x of 1. So for x of 1, what will be the value? N is equal to 6. Already we know that. So just put 6 minus 1. It will be equal to x of 5. Right? What is the value of x of 5? So here 0, 1, 2, 3, 4, 5. That is 3. Right? What is the value of x of 1? That is 3. 3 and 3. X of 1 is equal to x of 5. Okay? That has been matched. Now check for the next value. That is x of 2. So x of n minus 1. So n is 6. So 6 minus 2. That is x of 4. Now what is the value of x of 4? So 0, 1, 2. The value of at x is equal to 2 at this one is 2. Now what is the value of at that is also 2, right? At x is equal to 4 position. That means x of 2 is equal to x of 4. That means also it is following the circularly even function. Now check for the next values also. X of 3. Now x of 3, x of 6 minus 3. That means equal to x of 3. So x of 3 is equal to x of 3. That is 1. So 1 is equal to 1. Now further if you solve it, then you will find out the x of 4 is equal to x of 2. 6 minus 4 is equal to x of 2. Already we know that x of 4 is 2 and x of 2 already we have. Now further if you, so you can see that x of 1 is equal to x of 5, x of 2 is equal to x of 4, x of 3 is equal to x of 3. So that is means it is a 6-point circularly even function. It is following this property. X of n is equal to x of n minus 1. So it is 6-point circularly even function. Okay. Okay. So I hope.
Just a second.
Yeah.
Just a second. I want to see that one. Just a second.
Yeah. 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 You can check it.
Means simply we can say that it is shifted to number of places. I think so.
Yeah. You can also find
That
out.
is n minus of small n is nothing but where it is having the delayed signal,
Not
not
in that
delayed.
term.
Yes, delayed
Not
signal,
delayed. Yeah. It is a.
delayed itself. If
Yeah.
the
It
value
is
of x of
shifted
n
by
is
that
shifted
n
towards the
point.
right side,
Yeah. Yeah.
it
It
is
is.
shifted towards the right side means it is called as the delayed signal.
Okay, you don't need to go there. Here you have seen that the properties of the DFT. From here you have seen that is a even, circularly even and circularly odd. So if we shift any signal at n point, okay, n point, then in the frequency domain it will be shifted like n minus 1, or it has written x of minus k at mod n. So that means n minus k in the frequency domain. Here we are directly written in the time domain. Yeah, you can say that shifted by a endpoint. So just remember that this one, x of for circularly even, and for circularly odd, x of n is equal to minus x of n minus 1. Then if any signal or sequence follow this one, then that means that is a circularly odd function or odd sequence, you can say that.
I have a small doubt regarding this
Yeah,
one itself.
yeah, yeah.
For example, if they have given some 10-point information,
Okay,
for example, the value of x of 1 is equals to x of 10,
x of.
not this.
Okay, okay,
Just I am telling you example. If
okay.
the value of x of 1 is equals to x of 10 means, and
Hmm.
if you want to find out some x of 43 value,
Oh, x of
then how can
43.
we find out that one?
It depends on what is the sequence. N is equal to at what position it is going on, because DFT defined by a finite sequence, so that means
Yes.
n is defined. So
Okay.
if you are saying that, how you can get the x of 43 value, otherwise if the sequence is varies from 0 to 46, then you can find it out.
Means there we can't find out that one.
No, not like that. Otherwise the sequence is not defined. If sequence is defined that much of point, then you can find out.
The question is, for example, if the value of x of 1 is equals to x of 10,
Okay,
then
yeah.
find out the value of x of 53 or
50.
x of 47, whatever it may be, without having any information about the length of the sequence. Is it possible for us?
Then you have to assume that, by assuming okay and is varies, that is repetitive signal. Okay, so from here, you cannot define the length of the sequence. If you cannot define the length of the sequence, then you can find it out at position of 47 or 53, any position. So just you have to take that number x of, for example, you have to assume that in that case you have to take some assumption. Hello.
Okay, okay, okay. I will see that one.
Yeah. So have you understand this problem?
Yes,
I
yes,
think I
yes.
think you have seen some that type of question. Yeah, I remember it one that type of question, but I don't remember they have assumed some positions also,
No, no,
because for
no.
a
It
finite
doesn't have
sequence.
any positions. Simply they had given that in
So
previous
that must be a
papers
repetitive signal. In that case, if already you know that,
without mentioning the total length. How can we identify that particular value?
so
Means,
just
for example, if the total length is equals to 11, means the starting value of small n is 0 to n
so
minus 1. That is 0 to 10.
0 to 10. So that means that repetitive signal. So in that case, you need to find out, oh, okay, total length is 11. You are saying that. Okay, for
For
example.
example,
Okay, you need to
but they
find
did
out
not mention
at,
the total length.
yeah, at 43th position. So that means for every 11 position, that will start from 0 also, right? 0, then 1, then 2, till 11. Sorry, till 10. Then again, it will say, that means that repetitive one. So after 11 values, it will repeat. So that means till 0 to 10, you will take to that values that have been given. At 11 position, 11 is equal to 0, right? Then now next 11 to till what, 10 values. So that means 21, right? Or 22. Now next 22 value is equal to 0 value. So you have to take like this. That means that is repetitive signal.
A repetitive signal.
Yeah, that means repetitive sequence, not a signal, sequence.
Okay, okay.
So 0 to 10, take these values again, and at next position, that means 11 position, you have to take a 0 value, then repeat all those signals.
Means from
So
11 to 20 itself now we will obtain there, not 22. 0 to 10
that means
means the total length is
11. Okay, okay. So now next is 22, right? 11, 22. Now
0
next,
to 21. 0 to 21.
no. 0 to 10, any value. Okay, that means 0 to 10 is given, any value is given. Okay,
Okay.
you have that sequence like this. Now next at 11 position, it will again repeat at the 11 to 22, right? Now next 23 to how many
I have a
position?
doubt here. I have a doubt here.
Okay,
0
this,
to 10 means 0 to 10 means the value of x of 0 is nothing but x of 10. For example, let us assume
from,
that one.
yeah, it will.
Next, the same signal will be repeated from 11 to 21 itself, no?
Yeah, we are, because 0 to 10 we know that these signal, because these are the complex signals also, right?
Okay.
So 0 to 10 we have values, we can find it out. If we have 0 to 5, then from this property or DFT conjugate property, you can find out the next values. I
Okay.
have some questions that type of also. So we will solve that question. Then I think you are able to understand. So now next,
Okay.
for these values, in that case, repetitive signal, you can find out the positions 53 at any position, because these values are varying, repeating after that much. So from there you can get it. I hope whatever I want to say, you understand.
Yes, but there you told me that 11 to 22, but I am thinking that it is 11 to 21 only. Total 11 signals means 11 to
Okay.
21. It's
I am okay. Just take the 11 sequences, right? So I am
okay.
just giving example. You have to take it. So whatever it is.
Okay.
Now,
If we show one example means it is better for today's class. If not means we'll go through that of the next class.
yeah. You can take that question. I will solve. We will solve it here.
Okay.
Otherwise, I can take that type of question also, if I will find out. I remembering one question that type. So okay, I will check it. Check at that question. Okay, so moving to the next question. Now, next question, I think that can be helpful to solve that question also. So the first 8 point of a 8 point sequence is x of n is given, this sequence, right? And last two sequence we need to find out. Okay, where x n is the conjugate even periodic sequence, then value of x and y respectively. So here n is equal to 8 point DFT. That means the 8 point sequence is given. Okay, so now 8 point sequence is given, x of n is given, that is 8, 3 minus 2j, 10, 36 plus 24j, 5, 36 minus 24j x comma y. Now we need to find out the last two values of that sequence. So how we can find out? So from the properties of the DFT, so we can write out the x of n is conjugate even periodic signal. So x of n is equal to x conjugate of minus 1 for mod n. That means that we can write it like this: x conjugate n minus 1, right? N minus 1. It is a conjugate property of a DFT. X of n is equal to x conjugate n minus n, small n, where this n varies n 0 to n minus 1. That means 0 to 7. Total n is equal to 8, right? So here we know that it is at 0th position, right? 0, it is at 1, it is at 2, it is at 3, it is at 4, and this one at 5, and this one at 6th position, and this one is at 7th position. Okay, so total n is equal to 8 because it is 8-point DFT. So x conjugate n is given as 8. At what position we need to find out? That is x of 6, right? X of 6. And what is it? It is given as x of 6 position is x. So x 8, n is that is small, n is 6. So that means x conjugate of 8 minus 6 is 2. So x conjugate 2. So at 2 position, which value is there? That is 10. So it is not a complex function. So that it is a real. So it is only 10 only. Okay. Now next, that means x is equal to, that is x is equal to 6. Now next position is x of 7, and it is represented in this sequence as a y, right? So y is equal to x of 7. If we put in this equation, so x conjugate n is 8. At what position we need to find out? At 7th position. So 8 minus 7, that is x conjugate of 1. So x conjugate. So what is the value of 1 at position 1? 3 minus 2j. If you take the conjugate of that means 3 plus 2j, right? And what is the value at position? It is represented by y in this sequence. So that means x is equal to 10. That means at position x is equal to 6 and y is equal to 3 plus 2j. It is at position 7. Okay. Here it is only representation x and y are. So x is equal to 10 and y is equal to 3 plus 2j. So option C is the correct answer. Now here it is specified. It is a n-point DFT. If it is not specified and that it is 8 point given, so from here if you want to find out the at position, for example, let's say 24th position. Someone is asking this question.
Yes, yes.
So from here 6 7 till 7 you have got the sequence. So now if you want to find out at position 24, okay, so just repeat after 7. Now x of 8, what is the value of at x of 8? That means we will start from this at from here also again. It is a simple problem. If the sequence is n, then you take from starting. So x of 8 will be x of 0, and then put x of 9 is equal to x of 1 like this. Then at x of 24 position you will get, just continue that signal. Continue that signal at 24.
Okay, means the same signals must be continued.
Must be
After
continued.
we are going to obtain the value
At
what they
any
had
place.
asked you for that particular place.
Yeah, that particular place.
Okay.
If
Okay.
because the length of the signal is not defined, that's why.
Yes, yes,
That
yes.
signal
If
will
the
be
length is
repeated.
not defined, then we must continue that one.
That will be repetitive sequence. That will repeat after that point.
Okay, okay,
Yeah.
okay.
Okay. Okay. So moving to the next question. Now next question is, let x e to the power j omega is equal to n is varies from minus infinite to infinite, x of n e to the power minus j omega n, and x of n, that is inverse dt of t, is defined by this equation. If x e to the power j omega is given by this one, then what is the x of n in terms of unit discrete step function u of n? So any one of you want to solve this question? It's simple partial fraction. So can you find out what will be the solution for this question? Try to answer in the chat box. Okay, we need to find we need to get from the partial fraction, using the partial fraction. So already we know that. I'm just directly taking a to the power n u of n. What is the DTFT of this signal? That we know that 1 divided by 1 minus a e to the power minus j omega, right? A to the, if there is any signal a to the power n u of n, then corresponding DTFT of that signal is by this one. Or you can find out by this equation. Just put a to the power n here, and it is a unit step, so n varies from 0 to infinite. So if you take n common, so here, so a into e to the power minus j omega n will be the common, and it will summation. So already we know that 1 divided by 1 minus a e to the power minus j omega. It is the, we can get it from here. So using partial fraction, we can write this equation like this: 1 minus 0.2 e to the power minus j omega plus b divided by 1 minus 0.1 e to the power minus j omega, right? Can you find out and just let me know the values of a and v? You know that it is a very basic problem, partial fraction. You have solved many questions on that. So just let me know what will be the values will come a and v, and put it here. Okay, if you further solve it, you will get a is equal to 2 and b is equal to minus 1. You can solve it and check it. Okay, if you are solving, just let me know in the chat box. Okay, if you solve it, you will get a is equal to 2 and b is equal to minus 1. So if you put the values of a and b in this equation, 1 minus 0.2 e to the power minus j omega minus 1 divided by 1 minus 0.1, that equation here. So I have to remove it from here. So okay, so this is in this form only. So here what is the value of a? So here 2 into 0.2 to the power n un minus, I'm writing it here, 1 here in that one 1. So 1 into here 0 to the power 0.1. So that means 0.1 to the power n u of n. Okay, so you will find the inverse of that by using the partial fraction. partial fraction. So 2 into 0.2 to the power n u of n minus 1, 0.1 to the power n u of n. Okay, so which option is correct one? That is 1. Option 1 is correct. So just here for confusion or for any, they have given the DTFT and inverse DTFT also, and then they have asked by giving the DTFT signal what will be the x of n in terms of unit step function. Just use the partial fraction and convert it in the original form, that is x of n, in the form of x of n, then using the partial fraction, just simply. Okay, so I hope you have solved this question. So moving to the next question. Now next question is for a vector x of x bar that is given as x of 0, x of n to till x of 7, that is 8-point discrete Fourier transform, and is denoted by x dash, that is capital DFT of x bar, that is small df, that is, and it is represented by the capital X of 0, capital X of 1 to x till x of 7, because here it is given n is equal to 8, that means 8-point DFT. And the equation of DFT is also they have described by this x of k. Already we know that also x of k is equal to summation n is equal to 0 to 7 because n minus 1. So just n minus 1, so 8 minus 1 will be 7. X of n e to the power minus j 2 pi by n. Here n they have put it the value of n here, n k, and j is equal to root of minus n if x bar, that means this one is given as, this one is already given, the sequence is given 1 0 0 0 2 0 0 0, and y bar, now we need to find out the y bar DFT of x bar, small x bar, then the value of y of 0, what will be the value of y of 0? So here they have just round okay, what DFT of this, DFT of this. Okay, so already given x bar, that means x bar, that is DFT of x of n, that is x bar capital X. Okay, that is DFT of x of n, original sequence. Okay, so it is, or you can say that x of k, that DFT, if we represent in this form. The sequence is given as this one, 1 0 0 0 2 0 0 and 0. And see, equation already here it is defined. So now we need to find out y dash, that is DFT of x bar. X bar is already, it is a DFT. So that means x of, how we will find out the DFT, then again we have to take DFT x bar, then here we will get x bar, then again we have to take then DFT, you will get the y bar. And by the property of the duality, by property of duality, so already we know that x of n, if we take DFT, then again we have to take DFT of any sequence, it is represented by x of minus k, right? So DFT and DFT of x of n, that means is equal to y bar, and here it is n x of minus k. Okay, so x of k already it is given here, this equation. And then what will be the x of minus k? X of k is given in this equation, 1 triple 0, then 2 triple 0. What will be the x of minus k? By the duality property, it will be the same, 1 triple 0, then 2 triple 0, right? And DFT of x of n, it is given here n into x of minus k. So n here it is 8 point DFT. So 8 to 1 triple 0, then 2 triple 0, triple 0 only, it is not. So if you further multiply inside this, then you will get, I'm removing it from here, okay. Then you will get y of n is equal to 8 triple 0, then 16 triple 0. Okay, so now they have asked what is the value at y is equal to 0 at 0th position. So it is at 0 position, it is 1, it is 2, it is 3 till 7. So y of 0, what is the value of y of 0? That is 8. Okay, so the y of 0 value is 8 here. Answer is 8. Okay, so have you understand this? Okay, so I hope you have understand. So moving to the next question. Now next question is, consider the finite sequence x, that is 1 1 1 is given. The inverse discrete Fourier transform of x is given as x of 0, x of 2. Then the value of x of 2, what will be the value of x of 2? So what is the inverse DFT formula? That is x of n is equal to 1 by n, k varies 0 to n minus 1, x of k, which is given here, this one, e to the power j omega k n, or you can say that 2 pi by n in place of omega, 2 pi by n. Okay, so give here x, this one is given, so that means x of 0, x of 1 and x of 2, all this position the value is 1 only. So just put it here. So it is a three values are there, that means 3 point DFT is, it is n is equal to 3, that means 3 point DFT. So 1 by 3, k is equal to 0 to 2 n minus 1. So x of k e to the power j 2 pi by 3 k n. Okay, so at x is equal to 2 they have asked. So 1 by 3, now put the values of k inside this one, just expand this one. So 1 by 3, x is equal to 0 e to the power 0 plus x of 1 e to the power j 2 pi by 3 n, right, plus x of 2 e to the power j 2 pi by 3, in place of k there will be 2, so here I am directly writing 4 pi by 3 into n. Okay, now we need to put the values of x of 0, x of 1, all these values are 1, so 1 by 3, it will be 1 only, e to the power 0 it also 1, 1 into e to the power j 2 pi by 3n plus e to the power j 4 pi by 3n. It is a equation for x of n. Now they have the value of x of 2. So if we put n is equal to 2, we will find out x of 2. So at n is equal to 2, so that means x of 2 will be 1 by 3, 1 plus e to the power j 4 pi by 3 plus e to the power j 2, that means 8 pi by 3. Okay. If you further expand this, that means e to the power j 4 pi by 3 and e to the power j 8 pi by 3. We can e to the power j pi, we can write it in this form, cos pi plus j sin pi. Now expand all these in this form. So I have to remove it from here so that I can write. I hope all of you have noted down it. Now expand this further at x is equal to 2. So 1 by 3, 1 plus cos 4 pi by 3 plus j sin 4 pi by 3 plus cos 8 pi by 3 plus j sin 8 pi by 3. Okay. Now further how we can write it? We can directly solve it. If we want to further minimize this, we can write in this form, cos pi plus pi by 3, right? It will be the 4 pi only, plus j sin pi plus pi by 3. This one also we can write it, cos 2 pi plus 2 pi by 3, right? 6 plus 2 8, j sin 2 pi plus 2 pi by 3. We can write it in that form. Okay. So now I have to remove this part also. Okay. So now we can write it pi plus theta something. What will be the value? Cos pi plus theta. We will get minus theta, cos theta, right? So minus cos pi by 3, you can check it by yourself also, plus j pi plus pi by theta, we can write it like j plus j sin pi by 3 plus cos 2 pi by 2 pi plus theta. What you will get? Cos 2 pi by 3 plus j sin 2 pi by 3. You can check it. Okay. Cos pi plus theta, cos sin pi plus theta, or cos 2 pi plus theta, plus for that formula. So now 1 minus, what is the value of cos pi by 3? It is 0.5. Okay. And sin pi by 3 value is root 3 by 2. And for cos 2 pi by 3 value is also 0 minus 0.5, and plus cos j sin 2 pi by 3 value is root 3 by 2 only. Okay, so that is will be cancelled out. So j minus 0.5 minus 0.5, that will 1. All these values are will be cancelled out. So inside this, I am removing it from here also. All values are 0. So 1 by 3 into 0. So that will be 0 only. So x of 2 will be 0 only. Okay. Okay. So I hope you have understand this question to how to solve. So now moving to the next question. Now next question is, x of k is a discrete Fourier transform of the 6-point real sequence x of n. So x of k is given if x of 0 is 9 plus j0, x of 2 is given 2 plus j2, x of 3 is given 3 minus j0 and x of 5 is given 1 minus 1j, and then what is the value of x of 0? Okay, so what will be the value of x of 0? So all these values are given. So here some values are missing. Okay, it is, that means a 6-point real sequence given, that means n is equal to 6. So 0, here one value is missing, then after 2, 3, 4, at fourth position value. So first we need to find out at that position values, then we will find out x of 0. Okay, so how we can find out that missing values? By the conjugate property. By the conjugate property. Symmetry, conjugate symmetry property. Okay, so already we know that x of k is equal to x conjugate of n minus k. This is a conjugate symmetric property of a DFT. Okay, so which values are given in the DFT? X of 1, right? So x conjugate n is given 6, 6 minus 1. So x conjugate 5. That means conjugate of at position 5 value. So 1 minus 1j is this, then x of 1 will be 1 plus 1j. Now next one, which x at x of fourth position? So x of 4. So x conjugate 6 minus 4. That means x conjugate of 2. So 2 is 2 plus 2j. So conjugate, it's conjugated 2 minus 2j. So all values we have find, x of 0, x of 1, x of 2, x of 3, x of 4, x of 5 till 6 point. Now we need to find out x of 0. That means inverse DFT. Okay. So what is the formula of inverse DFT? IDFT. That is already we know that 1 by n. K varies 0 to n minus 1 x of k e to the power j 2 pi by n k n. Okay. So that means x of n it is, right? So just put the values, n is equal to 6. So at 0th position, at n is equal to 0 position, we need to find out. Okay, x of 0, because they are asking only for x of 0. So now k varies 0 to 5 x of k e to the power j 2 pi by 6. Here n is equal to 0, so whole will be the 0 only. So here it will left only summation k varies 0 to 5 x of k. That means summation of all the points from here, right? So I'm removing it from here, then just summation of all those points. Okay, so 1 by 6, that means x of 0 plus x of 1 plus x of 2 plus x of 3 plus x of 4 plus x of 5. Okay, so all those values we know that, just put it 9 plus j0, so don't need to write it here, plus x of 1, so it is just conjugate of that x of 5, so 1 plus 1j plus x of 2, that is 2 plus 2j plus x of 3, that is 3 plus x of 4, that is a conjugate of x of 2, that means 2 minus 2j plus x of 5, that is 1 minus 1j. Okay, so some values will be cancelled out, this one, this one, this one, and this one. If you further add this, you will get the 18. So 18 by 6, that is equal to 3. That means x of 0 is equal to 3. So from here, option 1 is the correct answer for this question. Okay, so I hope you have understand this question. So moving to the next question. Now next question is the sequence x of n is given, whether it is a circularly odd, circularly even, or option 3 is partly circularly odd or partially circularly even, neither circularly odd or neither circularly even. So already we have solved one question from this type. So I'm just telling you what is a endpoint circularly even. Already we have solved. Just we need to check whether it is a circularly odd or circularly even. Okay. So here it is given n is equal to 4, right? So for n points circularly even or odd, just we need to check if just we have to take only one, whether so even one is very easy. So I'm taking that one. If x of n is equal to x of n minus 1, then it is a circularly even. Otherwise, it is circularly odd. Okay, if it is not equal. So just check for x at one position, that is for 1. So x is equal to 4 minus 1. So that means x of 3. So what is the value of x of 1? So it is at position x of 0. It is at position 1 value. It is at position 2 value. And it is at position 3 value. Right? So what is the x of 1? Is 3. And what is x of 3? It is also 3. That means x of 1 is equal to x of 3. Okay. So it is matching with the circularly even function. Now next check for x of 2. So x of 4 minus 2. That means x of 2 is equal to x of 2. So x of 2 is 4. And here it is also equal. So x of 2 is also 4. Now next check x of 3. So x of 4 minus 3. That means x it is equal to x of 1. So x of 3 is 3. And already we know that x of 1 is also 3. So that means x of n is equal to x of n minus 1. So that means it is a circularly even sequence. Okay, so that means option 2 is the correct answer for this question. Okay, so moving to the next question. Now next question is 2-point DFT of a sequence x of n is x of k. X of k is given 6 to compute its inverse. Okay, now we need to find out the inverse DFT. Okay, so already we know that the formula of inverse DFT 1 by n varies 0, sorry, k varies 0 to n minus 1, x of k e to the power j 2 pi by n k n. X of k is given. Now we need to find out x of n. Okay, so here x of at its 0th position, it is at 1 position. It is only 2-point DFT. Okay, so first we will find out at 0 position, only two values we need to find. So n is equal to 2 here. So because it is a 2-point DFT, so k varies 0 to 1 only. X of k here at 0th position, so n will be 0. So whole upper part will be 0 only. It is just summation of these two values, x of 0 plus x of 1, right? So 1 by 2, just add these two. 6 plus 2, that is 8 by 2, 4. So x of 0, that means from x of n, it is a different one. The value we have got is 4. Now we need to find out the next sequence. That means x of 1. So just put in this equation. So 1 by 2 k varies 0 to 1, x of k e to the power j 2 pi by 2 k into 1, right? 2 will be cancelled out. So 1 by 2. So just I'm directly putting the k is equal to 0. So this function will be e to the power 0 will be 1 only. So x 1 e to the power j pi. Okay. Now what is the value of e to the power j pi? It is a cos pi plus j sin pi. Okay. So this value will come, cos pi will be minus 1 and sin pi will be 0. So minus 1 only. Okay. So 1 by 2, x of 0 is 6 into 2 plus 2 into minus 1. So from here 6 minus 2 will be 4. So you will get 4 by 2. So the x of 1 will be 2 only. If you further here also 4 by 2 will be 2. That means x of 1 will be 2. So x of n, what we have got? X of n is equal to 4, 2. Okay. So option 4 is the correct answer for this question. So I hope you are getting this question. Just a minute. So you have understand this question. So moving to the next question. So here for a discrete time sinc function, what is the inverse discrete time Fourier transform of a function as shown in the figure? So in the form of inverse TTFT, we need to find out in the form of sinc function. Okay. So for inverse TTFT, we know that formula x of n is equal to 1 by 2 pi integration of minus pi to pi x e to the power j omega e to the power j omega n d omega. Okay. And here x e to the power j omega is defined 1 for mod of omega is less than this omega and 0 for when omega from here to here for this function. This is an equation. Okay. Now if we will put in this equation, so you will get 1 by 2 pi minus pi to pi x e to the power j omega in the form of that one e to the power j omega n d omega. Okay. From here it varies, that is 1 from minus omega to omega, this one w. So if you further put it minus omega to omega e to the power j omega n d omega. So you will get it, if you further do that, 1 by 2 pi e to the power j omega n, where it varies by minus omega to omega divided by j n, right, with respect to this omega. Now if you put it okay, I'm removing it from here. Just running out of time, so okay. So what we will get, 1 by 2 pi if we all take j n, right, and here it is e to the power j omega n minus e to the power minus j omega n. If we put it right here, e to the power, in place of this omega we have to put this one minus this one. So final we have got this one. So what we can write it, e to the power j omega n minus e to the power minus j omega n divided by 2 pi. We can write it as a sin omega n, right? We can write it sin omega n divided by jn. We can write it like this, not a jn, sorry, pi n. 2j will be the sine function. sine omega n can be represented e to the power j omega n e to the power minus j omega n divided by 2j, right? Sine omega n, it is represented by this. So from here we have written sine omega n divided by pi n. So now if we want to convert into a sinc function, so how sinc function is represented? Sinc x is equal to sine pi x divided by pi x. It is a sinc function, right? So making in this form, what we need to do? Just multiply omega and divide by omega in this outside. Then we will find this one. Multiply and divide by this omega. And in order to make sinc function, by omega. So omega sine omega n divided by omega pi n. So sine omega n divided by omega n, it will make a sinc function. So omega divided by pi sinc omega n. It is a sinc representation of this signal. Okay. So this one is a final solution. So if it is matching, omega divided by pi sinc omega n, not a 2 pi. So it is a final one. From here, I think something is wrong. If I will find anything, then I will let you know in the next class. I will take it again. Okay. But final sinc, it is a sinc function. Okay. So this is a representation of that this figure DTFT representation. Okay. So moving to the next question. I hope you have understand. Any one of you have any doubt? Okay, so moving to the next question and last question. So let the finite length signal x of n is represented by this. Then what will be the DFT? So here it is a 4-point DFT. So already we know that for 4-point DFT, one way to solve from this equation, n is varies from n minus 1 x of n e to the power minus j 2 pi by n kn. But for 4-point DFT, there is a direct formulation to convert into a x of n by a linear transform view, right? From using the linear transform view, we can directly solve for 4-point, only 4-point till 4-point DFT using linear transform view. So it is represented by x of k 1 1 1 1. It is a W matrix 1, then minus j minus 1 j 1 minus 1 1 minus 1, then 1 j minus 1 minus j, and here x of 0, x of 1, x of 2 and x of 3. Just put the values of x of 0 and then do the matrix multiplication. You will get it 1 1 1 1 1 j 1 j, that's minus minus, and 1 minus 1 1 minus 1 1 j minus 1 minus j. So j minus 2 minus j 1. The values of x of 0, x of 1, x of 2, x of 3. Okay, just do the matrix multiplication. So I have to remove it from here. So if you further do the matrix multiplication and addition, you will get j into 1 j 1 into minus 2 minus 2 then 1 into minus j, 1 into 1 plus 1. Similarly, you have to just multiply. So j plus 2j plus j plus j. Just you check it. Okay, I am writing here. So j plus 2 minus j minus 1. Now next one is j minus 2j plus j minus j. Okay, now if you further solve it, you will get minus 1 from here, because this one will be cancelled out, minus 1 from here also. So all the additions, so 5j. Now here minus 1 minus 2 minus j. No, something is wrong. So here it is j. So this one will be cancelled out. 2 minus 1 will be 1. Okay, now here, so j, 3j minus 2j. So yeah, it is 1 and plus, yeah, here it is minus j is here. Okay, so this one will be cancelled out. So j minus j will be there. So what we have got, x of n minus 1, 5j, then 1, then minus j. Minus 1, 5j, 1 minus j. So option 4 is the correct answer. Okay, just remember this for 4-point DFT in order to compute. So you can directly use this transformation. Okay, that is linear transform view, that W vector. So y is equal to W x. Where is the y is the output vector, W is the matrix, that W to the power kn vector, and x is the input vector. Okay, okay, so I hope you have got this question. So now for this week, these are the total questions. Okay, now if you have any doubt, you can ask, otherwise we can close the session. So thank you everyone, thank you for joining this session. If you have any doubt, you can ask, otherwise we can close this session. Anyone? Anyone have any doubt? So if you don't have any doubt, you can leave the session.
Okay, thank you, ma'am.
Yeah, thank you everyone, thank you for joining this session. Now we are closing this session. We will meet in the next session. Okay, so thank you everyone, thank you for joining.